This first example is based on a project that a group turned in, I think about a year and a half ago. I didn't assign exactly the same project then, but the main idea would translate, and I just had to improvise a couple of things to get this to work for our project. The two big things for why I wanted to use this type of example are that this is one where the data is collected from scratch. So this was one where, in order to get the data, it was go out and actually do the measurements yourself. And it's one where the sample size ends up not being all that big. But the other big thing is that the concept for what the inference is going to be about is pretty simple. And generally that's a good thing, because if the overall concept is pretty simple, then it's easier to follow along with. It's easier to piece together what you have to do inference-wise. And generally, it just makes the project easier to handle. And the easier to handle the project is, usually the better it turns out. So the first thing, the topic, Gala apples at Kroger. So in order to collect the data, it does end up being going to Kroger and weighing a bunch of apples individually. The topic would be something like that, or the average weight of Gala apples at Kroger. Something to that effect. Writing out what your topic is, I think that's 1 or 2 sentences. I have it kind of in shorthand here, but you could certainly embellish that a little bit. But really, it doesn't need to be anything terribly long. The next thing that I put in here was the constant term. That's the first thing that you see if you go to that URL. You have to scroll down a little bit in order to get the value that we're going to have to use for the hypotheses. If you scroll down a little bit, you do get it. You don't get that red box. I added that in there for emphasis, but the 140 is what you want. So according to Livestrong.com, an average medium-sized Gala apple weighs 140 grams. There's a value that we can put into our hypotheses, because this is going to end up being a one sample test. So if it's one sample, you do need to have a constant term in there, and here's our constant term, the 140. As far as an explanation for where the constant term comes from, if it's something like this where you're pulling it directly off of a website, I would imagine that that would really only be 1 or 2 sentences as well. Basically, you just end up saying where it came from. Here, this is coming from Livestrong.com, and there's an article there about Gala apples, and it's right in that article. There really isn't anything to add beyond that that really has to be in there. The next thing, picking an inequality and writing out the alternative hypothesis. This is a scenario, like it says toward the bottom, where it's not the case where there's one correct inequality and the other 2 are incorrect. It doesn't work that way. And most examples don't. There are some that do, and like the one with the cars with the different years where it's the same make and model, sure. But for a lot of things, you do have options as long as whatever inequality you pick, you have some sort of justification for picking it. So for this one, if there is a good reason to prefer larger or smaller apples, then maybe you would want a one-sided alternative. Maybe if you end up cutting up apples a lot and that's easier to do when the apples are smaller, then maybe that's the thing that you're going to be looking for, because then if the apples are smaller, you'd be more motivated to go to Kroger and buy them there, because they're going to be easier to cut up. But without that sort of thing, I think having the two-sided alternative here would probably be the most straightforward one for most people with this subject matter. And that's the thing that's in bold toward the top, that the average weight of Gala apples at Kroger is different than 140 grams, different than being the two-sided alternative, of course. As far as a justification for the two-sided alternative is concerned, I suppose here it ends up being that we have this value from Livestrong.com, and we want to see if that's applicable at Kroger. That's supposed to be a universal value, and we're saying, okay, well, now if we look at this specific situation, where the specific situation is buying apples at Kroger, buying Gala apples at Kroger, does that 140 still work? Or at Kroger, is it something else, where something else could go either way, maybe bigger, maybe smaller? So if you're using the two-sided alternative here, really it's just seeing, does that 140 grams value, is that going to hold up at Kroger, or really do you have evidence that that does not hold up at Kroger? For the data collection, here it's from scratch. It's going to Kroger and weighing apples individually. So like it says there, 30 Gala apples weighed individually, Euclid Kroger on July 16th. By the way, all the numbers are made up, but I needed those specifics in here to actually get this to make sense. So this didn't actually occur, but just play along. The other thing that I want to point out here, and this is why there's that screenshot, is that the sample size is less than 40, and this is a situation where that's totally fine. Because if you look at that screenshot, it looks like it's supposed to. It looks like a bell shape. For writing out the p-value in words, it doesn't have to be anything overly specific. As long as you follow along with the general definition and you get the specific numbers in there, I think that's enough. Even having the units, even having the grams, I don't think you need that in this case. So the main things, I suppose, would be you need to get the cutoff in there. You need to get the assumption that the null hypothesis is true, whatever that is. It's going to be mu equals some number, or p equals some number, or the two population means are the same, or the two population proportions are the same. And I guess the only other thing is that if it's a two-sided alternative, then you want to be doubling a tail. I've got that with the word twice that shows up at the beginning of that blurb. That's really all you have to get in here. This part you could make a lot longer if you wanted to, and I suppose there's nothing wrong with that, but you don't have to. I put the data into StatKey, and this is what I got for the p-value. So I made the CSV file first and then uploaded it. I'll show you how to do that at the end of this video. But once I got the data in there, then I just looked under where it says original sample in the upper right, and I said there's the sample mean, 136.633, so that's going to be my cutoff. And it's a two-sided alternative, so in the upper left I wanted to pick two tail, and then I just changed the cutoff for the left tail to 136.633. Since that number is less than 140, so that should be the left tail cutoff, not the right tail cutoff. And then it looks like what you end up with is a p-value of 0.49. This slide contains the next two bullet points in the project instructions. That first part, the p-value being 0.49, bigger than 0.05, so you shouldn't reject the null. That's the statement including the p-value and the decision about the null. So that's really as long as that has to be. You just need to get the p-value in there, and then you're just comparing it to 0.05. And just like you would in Chapter 4, p-value less than alpha, you're going to reject the null. The p-value is not less than alpha, like it is here, where it's 10 times as large, then you don't reject the null. The formal conclusion, I have a shorthand version of it underneath, where if you don't reject the null, you end up saying there's insufficient evidence to conclude what's in the alternative hypothesis, which here would be that the average weight of Gala apples at Kroger is different than 140 grams. So that part is just sort of recycled from where the alternative hypothesis shows up earlier. So when you got down to this part of the write-up, you'd already have the alternative hypothesis written out, and you can just sort of graph that in here in that formal conclusion. The last thing in the write-up, any reservations or limitations regarding the conclusion based on the way that the sample data was collected? Well, let's see. All of the Gala apples that were weighed were at one Kroger. They were all at the Euclid Kroger, and it was all done in one day, all on July 16th. But the population of interest, the way that the hypotheses were written out, or the way that the hypotheses were formulated, appeared to be all Gala apples sold at Kroger without those restrictions. So anytime at any store. If that's what the population is supposed to be, then we do have a couple of restrictions as far as how far we could generalize, because it is all one day and all one store. There could be variation there from one store to another or one day to another. Maybe not every shipment is going to have the same weight distribution from one apple to another. That's the sort of thing that you want to get in there. I guess here I have two reservations or limitations, whatever you want to call those. And like I said in the instructions, make sure that you get at least one in there. But for something like this, those two are pretty automatic. And if it's something like that where you think of a couple right away, then by all means, put them both in there. I think that's really what you want to do. This last slide just shows what the CSV file should look like. Basically, it looks like an Excel spreadsheet, and that might be the easiest way to make one from scratch, where if you open up an Excel spreadsheet, and then in this case where it's for a single sample, just make sure that you have the header. So I have Gala sample. I mean, I just put a generic header in there, but you can use whatever you want as long as it's something where you know what it is, I suppose. And then underneath that, you just have the individual values. That's about all you have to do. And then when you save it, just go to Save As, and then you need to change the file type to CSV, and then in parentheses, comma delimited. There are probably going to be several CSV options, but you want that generic one where that's how it's phrased. It's written as CSV and then comma delimited in parentheses. The last thing in this video, importing the data into StatKey, and this will also kind of show why you want to have a header. So this is a test for a single mean, And then I'm going to upload file, since we're not going to retype the individual values. And then the one called Apple sample data, that's the one that I want. And then where it says here, please select a quantitative variable, this is what the header is for, because then you just click on the header, and then it selects that column, and then OK. And then if you look up here, sample size of 30, I got my sample mean, everything's in there. Then you just have to change the value in the null hypothesis, which in this case is 140. And then you can generate your 5,000 bootstrap samples. It was a two-sided alternative. Change the cutoff here to 136.633. And there's the p-value. I get a slightly different one this time than what I have in the slides, but that's normal. Right, one randomization distribution to another, they're not going to be identical since they're randomly generated. So I'm getting a slightly different p-value, but there's nothing wrong with that. There was one other thing I wanted to add to this video, which was the second page. I posted this on Canvas as its own file, but I figured there were a couple of things worth pointing out. The hypotheses written in symbols, so the first thing that I've got there, yours ought to look pretty similar to that. I mean, granted, maybe you're going to have a different inequality in the alternative hypothesis. Maybe you're going to have a two-sample problem instead of a one-sample problem. Or if you've got a one-sample problem, you're going to have a different constant term in there. Sure. But generally, writing out your hypotheses in symbols, just use the Microsoft equation editor to put it together, or whatever word processing software you're using, it's going to have an equation editor, and just use that. This particular example does not have a sample data screenshot because the sample data don't come from a website. If that doesn't happen, there's no screenshot. This was one where the data were recorded from scratch at Kroger, so there's no screenshot there. There is one for the constant term, which is that Livestrong article. So I made that red box and just boxed in the important thing, so the part of the sentence that actually states the constant term. You don't have to do that if you don't want to. It does admittedly make things a little bit simpler on my end, but I'm sure I can find your constant term in your screenshot. That's not going to be a problem. As far as the URL is concerned, I guess you got a couple of options, and I did both because I included it down here where I retyped it, and also I cropped my screenshot so the location bar was still visible, so it's actually up there too. You don't have to do both things. One or the other would cover it. So either if you crop your screenshot so the location bar is in it, that's enough by itself. Or if you crop your screenshot to where the location bar is not in it and you retype the URL underneath, that's okay by itself too. Lastly, there's the p-value screenshot down here from StatKey, which looks kind of grainy for whatever reason. At least in the dot plot, it looks kind of grainy. So that's really what you have to get in there. I guess the big things are that you would need the dot plot with this above it where it says randomization dot plot of x bar null hypothesis mu equals 140. I would say make sure you get all of that in there and then get the original sample box. The easiest thing to do is just to take a screenshot of your entire screen and then just crop it down to basically what I have here, and then you'll be covered. I did it in the way that I thought would be the simplest, even though I know if you do it as multiple screenshots, you can make the original sample box bigger. You can do that if you want to. That's a nice thing to do, but you don't have to. If yours looks like mine, that is certainly going to work.